Here we are going to test 19 functionality and its combination in a short interval of time. This type of testing is useful for testing big projects like Axiom Systems Photo Editor. For testing this large number of functionalities and combination, we have to first memorize with the algorithm. The algorithm is known as position exchange circular shifting algorithm. Here we assume that the functionalities are different types of objects and any functionality can come to the first position, and if it comes to the first position from any other position, that vacancy should be filled by the first functionality. This is the second iteration actually. Here we are exchanging the position of 1 and 2. Since the second functionality is able to come to the first position, then the second position should be replaced by the first position. This is the third iteration, and here we are exchanging the position of 1 and 3. Since the third functionality can able to come to the first position, we are replacing the first position with the third position and completing the iteration. Here this is the fourth iteration actually. Here we are exchanging the position of the for 1 and 4. Here the fourth functionality can comes to the first position, and the first position should be replaced in should come to the fourth position actually. From the above algorithm, this is the position exchange circular shifting algorithm, we have concluded that if we have n functionality, then we have n square iterations. Here we assume that we have got only 4 functionalities and we are getting the 16 iterations actually. For testing the 19 functionalities combination effectively and fastly, we have the position exchange circular shifting algorithm. Since these 19 functionalities are placed one after other, it is assumed to be a continuous function with fx is equal to x. So it has got a minimum value and a maximum value. Minimum value is taken as 4 and maximum value is taken as 8. This is because if we take 3 as minimum, if we take 3 as the minimum value, then we have then the iteration becomes like this. Here we are not getting then n square number of iterations actually, since the iterations are repeated, which is represented in the red color actually. Since we have 19 functionalities, we have n square iterations. That is 19 into 19, that is 361 iteration, which is a huge value. So to reduce the iteration, we have fixed the maximum value as 8 because we have taken the maximum value as 50. Since 8 square is 64, which is above 50. Since 7 square is only 49, we can take only 8. Now we have the minimum value for iteration as 10. Then only one value is suitable, which is 4, which is 4 square is 16, which is above 10. So minimum value is 4 and maximum value is 8. Since we have 19 functionality which gives 361 iteration which exceeds the maximum value, that is 50, we have to divide the functionality using the central pivot method. In central pivot method, we should divide the functionality in such a way that it should be near to the pivot. So now we are going to divide 19 functionality using central pivot method. So now we are going to see what is central pivot method. We have got 19 functionality. If we divide equally, it becomes 19 by 2, that is 9.5. So 9.5 is the pivot. Now we have to group the functionality in such a way that the value should be near to the pivot and it should be within the minimum and maximum value, that is 4 and 8. Since 8 is maximum value, we have to subtract 8 from 19, which is 19 minus 8, that is 11. This value we cannot divide equally. So we take 19 minus 7, which is 12. This value can be divided equally, which is 6. And it is near to the pivot, that is 9.5. So one value will be 7, another value will be 6, and other two values will be 7 and 6, 6. So we have grouped the 19 functionality as 7, 6, 6, which is within the range and near to the pivot. Here now we apply the position exchange circular shifting algorithm to the grouped data actually. Since we have n functionalities, we have n square iteration. Then the vectors become 49, 36, 36. A is 49, B is 36, C is 36. Now we have the equation a square plus b square plus c square is equal to ab plus bc plus ca if a is equal to b is equal to c. Here we have 49 iteration, that is we have 36 plus 13 extra iterations, and others are 36 iterations. So we have a is equal to b is equal to c. So if you apply the algorithm and add the groups, you will get all the combinations. Here we get all the combinations as per the equation, since a is equal to b is equal to c. Here we are going to see the steps to test the 19 functionalities and combinations. Step 1. Check the size of the functionality. If it is more than the maximum value, we will divide it. Step 2. Divide the functionality using central pivot method, and it should be within the minimum value and maximum value. Step 3. Apply the position exchange surplus shifting algorithm. Step 4. Verify the result using the algebraic equation a square plus b square plus c square is equal to ab plus bc plus ca if a is equal to b is equal to c to get the combination of the functionality.